Everyone, I'm going to explain about the comparison of E1 mechanism, E2 mechanism and E1cb mechanism. So in this video, we will be covering the comparison about all the three mechanisms. To start with a short motivational quote, 99% of the failures come from people who have the habit of making excuses. This was mentioned by George Washington Carver. So let us be positive to succeed in life. So coming to the comparison. So E1 mechanism, it is a two-step process. E2 is a one-step process and E1cb is a two-step process. So in E1 mechanism, what happens is the C leaving group bond breaks and CH bond breaks and CC pi bond is formed. Okay, whereas in E2 mechanism, it is a one-step process where everything takes place in a single step, that is CH breaks, CC pi bond is formed and C leaving group bond breaks all at the same time. And E1cb mechanism is two-step process in which the CH bond breaks and carbanion is formed and C leaving group breaks and CC pi bond is formed. So here it is shown very clearly in the next step. See here, carbocation is formed, okay, and it is a concerted mechanism, and here it is carbanion is formed. So carbocation intermediate, no intermediate concerted, and carboanion intermediate. So carbocation is stabilized by electron donating groups, whereas carbanion is stabilized by electron withdrawing groups in E1cb mechanism. So in E1 mechanism, assisted by good leaving groups, whereas here in E1cb, it is assisted by poor leaving groups. So even it is no strict requirement on stereochemistry of CH and CLG, whereas in E2 mechanism, as I told you, it should be anti-periplanar. The CH and the leaving group should be in opposite directions, and E1cb mechanism, there is no strict requirement on stereochemistry of CH and C leaving group bond. Okay, so நம்ம ஸ்பெசிஃபிக்காக கொஞ்சம் சிம்பிளாக பார்த்துக்கலாம். இந்த explanation, I think it is very clear. Okay, so rate is equal to rate constant into substrate concentration, whereas E2 mechanism, it is bimolecular, so it is based on the concentration of substrate and the base, whereas E1cb is unimolecular because it is based on the concentration of the carbanion, that is substrate molecule. So E1 is unimolecular, E2 is bimolecular and E1cb is unimolecular. ஸோ பார்த்திங்கன்னா இதில் வந்து ஃபஸ்ட்டு என்ன ஆகுதுன்னா, லீவிங் குரூப் வந்து ஃபஸ்ட்டு வந்து ரிமூவ் ஆகுது, அதனால நமக்கு கார்போகேட்டையான் ஃபார்ம் ஆகுது. ஓகே, அதுக்கப்புறமா என்ன ஆகுது, ரிமூவல் ஆஃப் ஹைட்ரஜன் takes place. Whereas in E2 elimination, concerted both proton and the leaving group are eliminated simultaneously. Whereas E1cb mechanism, hydrogen is first removed. Okay, so acidic hydrogen is removed, அதனால என்ன ஃபார்ம் ஆகுது, கார்பானியான் ஃபார்ம் ஆகுது. அதுக்கப்புறமா என்ன ஆகுது, லீவிங் குரூப் வந்து ரிலீஸ் ஆகுது. ஸோ E1 எலிமினேஷனில் வந்து டெர்ஷரி ஹாலைட்ஸ் வந்து is preferable, whereas E2 no such preference, whereas E1cb substrate with electron withdrawing groups such as ketone, nitrile or nitro group is preferred. In E1 mechanism, no strong base is required, whereas E2 elimination, stronger and bulky base in higher concentration is required, whereas E1cb elimination, strong base is required. ஸோ ஈவன் எலிமினேஷனில் என்ன ஆகுது, லெஸ் அசிடிக்காக இருந்தால் ஆல்ஃபா கார்பன் போதும், E2வில் வந்து அசிடிக் ஆல்ஃபா கார்பன் இருக்கணும், E1cbலேயும் மோர் அசிடிக் ஆல்ஃபா கார்பன் இருக்கணும். ஸோ நோ ஸ்டீரியோகெமிக்கல் requirement. E2 mechanism, the leaving group must be trans to the hydrogen involved in anti-elimination, and E1cb no stereochemical requirement. E1 elimination is strongly dependent on leaving group. Hydroxyl can be converted to a better leaving group while protonation by use of an acid. E2 elimination, hydroxyl can never be a leaving group for E2 elimination, and even CB, poor leaving group which makes the acidic proton at beta carbon. Okay, so let us take the comparison of the energy level diagrams for E1 reaction. So see here, you find that there are two peaks, okay, for E1 mechanism. For E2 there is single peak present, and for E1cb you find that first one is a small one and the second one is a of larger activation energy. I hope this video was very useful. So I had compared the three mechanism of elimination reaction. Okay, so see you in the next video with another content. Thank you.